In this tutorial, we are going to talk about functions, but we are going to focus on the polynomials using synthetic division, long division, and also the factor theorem. Then apart from that, we'll also go further and also talk about sketching polynomials. Then from there now, we are going to also talk about radical function and rational functions. How to sketch the rational functions, how to sketch the radical functions, and also how to find the modulus inequalities. So let's begin our discussion with this first question, which is saying use long division to divide the following polynomials. So the first question is 2x to the power 3 plus 6x to the power 2 minus x minus 3 by 2x to the power 3 minus 1. So we want to use the long division method to divide this. So long division, I hope you guys you are familiar with it. It's not something that is complicated, but we need to know and follow these simple steps. So this dividend is the one which is going to be here, 2x to the power 3. But after x to the power 3, there is x to the power 2. So it will be 0x to the power 2. After x to the power 2, there is just x, then minus 1. Then this guy has to be here. 2x to the power 3 plus 6x squared minus x minus 3. So let's see. If I do 2x to the power 3 divided by 2x to the power 3 is 1. So 1 has to be written straight with the guy which doesn't have x in this manner. So now 1 times everything what I have here, it will give me the same thing. So I'll end up having 2x to the power 3 plus 0x to the power 2 plus 0x then minus 1, not so. So if I do minus right now, I'll end up having this is going to be 0. 6 minus 30, it will be 6x squared minus x minus 4. So now we have divided, now we end there. I can't divide this into that because this is bigger than x squared. So it ends there. So this is my quotient, this is my remainder, and that's my dividend. As simple as that. So now I can use the same concept to solve question 2. Okay, I'll use the same concept to solve question 2. So question 2, using the same concept, we can clearly see that we are going to have this. So the dividend, write it here, 3x squared. After x squared, it should be just x, so 0x minus 2. Then this one, 3x to the power 3 minus 12x squared minus 2x plus 8. So 3x squared into 3x to the power 3, it is just x. X has to be written straight with the guy which has got x on. Okay, so I can use a different color. Let me put x. So x times everything here, I'll have 3x to the power 3 minus, or it will be plus 0x, because 0x times x is just 0x squared. It's not squared, right? Yes, it's going to be squared. So it is 0x times x is 0x squared. Then this now times that, it will be minus 2x. So let's see. If we do minus here, this will be 0. Negative 2x squared minus this, it will be negative 12x squared. Negative 2x and that, it will be the same as 0. So I can leave that. So then I'll drop this. So it's the same as 0x then plus 8. So now I'll say 3x to the power 2 into negative 12x squared. So I'll end up having negative 6. Negative 6 times that, I'll end up having negative 12x squared. then plus, again this will still be the same, 0x, then minus, it will be negative, or plus negative that plus that is 12. So if we do minus here, we'll end up having this 0, 0, then this is negative 4. So this is my remainder, and that's my dividend. So using long division, I'm done. So I want you guys to go ahead and solve this, but let me go ahead and solve this for you. Okay, so let's see. Using the same method, I believe this is not going to be complicated at all. So the dividend is x to the power 3. So I'll do it like this, x to the power 3. The next one is 0x to the power 2 plus 0x minus 1. Then this one is x to the power 5. The next one is 0x to the power 4. The next one is 0x to the power 3. The next one is 0x to the power 2. The next one is 0x, then positive 7. So x to the power 3 into x to the power 5, it is x to the power 2. So it will be written here, x to the power 2. So if I do x to the power 2 times everything that I have here, I'll end up having x to the power 5. Then another one will be 0x to the power 4. That one will be 0x to the power 3. Then this one will be minus x to the power 2. So if we do minus, what do we expect to have? So this and this is 0, this and that is 0, this and that is 0. Then this and the negative x is just positive x to the power 2. Then now I'll bring 0, it's not going to affect anything. I'll bring positive 7 here. So then this is my remainder, and that is my quotient. Okay, yeah, that's my quotient and that's my dividend. As simple as that. So nothing is complicated for question 1. Let us go ahead and also talk about question 2, which is saying write each of the following polynomials in the form of x plus or minus p. Then we have that. So this is one of the simplest thing. We have been given the factor already. We can use synthetic division in this case. Okay, so what do I mean? We'll get this x plus 1 is equal to 0. So for x is equal to negative 1. So then we already know this part here, which is this, and we want to find that one. So using synthetic division, I'll have neg1 here. The coefficient of those is 1, 6, 8, and 3. It's x to the power 3, x to the power 2x, then the number without x. Bring this down, 1 times negative 1, negative 1. So then this is going to give me positive 5 times 5, or it will be negative 5, then it will be 3, negative 3, then 0, which is the remainder. So this will be 1x squared, which is x squared plus 5x plus 3x. So this is now in a form of that. So we want to write it in the form of that. We start with this, which is x plus 1 and x squared plus 5x plus 3. This is not supposed to have x. Plus 3. That is the answer. The example that I've given you here, I believe you can even solve the rest. You can do the rest. Everything is just okay. So let us go ahead and solve one more, and then you guys are going to do the rest. So let me go and do this one. Okay, so x minus 5 is equal to 0, then x is equal to 5. So using synthetic division, we have 5 here, so we have 1, neg 8, 13, and 10. Bring this down. 1 times 5 is 5. Negative 5 plus negative 8 plus 5, it is negative 3. Negative 3 times that is 15. So 15 is negative 15. So this will end, it will give me negative 2. Negative 2 times 5, negative 10. The remainder is 0, which is making sense. So then 1x squared, which is x squared minus 3x minus 2. So we already know what this is, which is x plus or minus. So we have x minus 5 and x squared minus 3x minus 2. So this is the answer. So you guys go ahead and do part 2 and 5. This was supposed to be 4 though. Yeah, go ahead and solve those two and then send me the answer in the comment section so that I check it out. Okay, let us go ahead and talk about question 3, which is saying show that x to the power 3 plus x to the power x 2x squared minus 5x plus minus 10 is equal to that. So here you choose. It's either you can show that this is equal to that, or you can show that this is equal to that. So I'll do both. So here I can separate these things. I can do this one alone and this one again alone. So the first one I can factor out x to the power 2. So here I'll remain with x plus 2. Even here I can factor out negative 5. I'll remain with x plus 2. So we know that if these are the same, you pick one. So you end up having x plus 2 and x squared minus 5. So this is exactly as that one. If you want to show that this is equal to that, expand this and you are going to have that. Nothing is complicated on this question. So let us go ahead and talk about question 4. So question 4 is saying find the remainder when part 1 when x to the power 3 plus 4x to the power 2 minus 3x plus 2 is divided by x plus 5. So here you can use different methods, but in this case I'm going to use synthetic division because I see it to be the simplest one. So when I want to use synthetic division, this guy is what we call the dividend. Okay, so then what I have to do, I need to get x plus 5 I equate equal to 0. So for x will be equal to negative 5. Using synthetic division, guys, I clearly see that I'm going to put negative 5 here and the coefficient of this has to be here. So it will be 1, 4, negative 3 and 2. Let's bring 1 down. So 1 times negative 5, it is negative 5. Negative 5, so I'll say 4 plus negative 5 is negative 1. Negative 1 times negative 5 is positive 5. Negative 3 plus 5, that is 2. So 2 times negative 5, that is negative 10. Positive 2 plus negative 10, that is negative 8. So this number you are going to have to the right side here, this is what we call the remainder. Okay, so in this case there is no need of us wasting time, and we'll go ahead and conclude that our remainder is negative 8. Okay, the question is just asking us to find the remainder. So our remainder in this case is negative 8. So using the same concept, what if I go ahead and do part 2? So part 2, same thing. I have to get the dividend. I'll say x minus 6 equal to 0. So for x is equal to 6. So then using synthetic division, I'll put 6 here and I'll put these guys in order. So I have 3, negative 20, positive 10, okay, and positive 5. Bring 3 down. So 3 times 6, it should be 18. So negative 20 plus 18, that should be negative 2. Negative 2 times positive 6, that should be, so I'm doing this times that is going to give me 12. That will be here, so it's negative 12. 10 plus negative 12, that is negative 2 again. Negative 2 times that, it will give me negative 12 again. Then if I add 5, and it should be 7, negative 7. Not so. So then I can clearly see that the first one, what we're going to have, it will be basically negative 7. Is this correct? Yes, this should be correct. Okay, yeah, so this should be correct. So we have 3, we have brought 3 down, and we found that this 3 times 6 is 18. That is what I have here. Negative 20 plus this negative 2. Negative 2 times that, negative 12. If I add this negative 2 again times that, so I end up having my remainder to be what? To be negative 7. So you can either use synthetic division or long division. Now this is my remainder. So my remainder in this case is negative 7. Okay, yeah, my remainder in that case is negative 7. Another way on how to find the remainder is simply just plug in the values. What do I mean? You plug in this value into x. So if f of 6 should be equal to, so where there is x, put so where there is x, put 6, and then you raise to the power 3. So this was supposed to be raised to the power 3, not 2. Yeah, it's supposed to be raised to the power 3, not 2. So you raise it to the power 3 minus 20, then again 6 raised to the power 2 plus 10, 6 plus 5. So the answer you're going to find, that is going to be the remainder. So like we said, the remainder is negative 7. Let's now prove here. So we do have 6 raised to the power 3 times 3, that is 648. So this minus, okay, so we have minus, then this is going to be 6 times 6 squared, then times 20, that is 720. 720 plus that is going to be 60 plus 5. So if we add these numbers, we should be able to get negative 7. Let's see. So 648 minus 720 plus 60 plus 5. We should be able to get negative 7. So negative 7 is my remainder in this case. So as you can see, I've used a different method here. Even here, now I can also use long division. So the third question, this one, let me use long division. But long division is going to take a bit of time, but instead of me wasting time, let me just use simple one. Equate equal to 0, so for x is equal to 4. So where there is x, put negative 4 or positive 4 to the power 3, then 4 raised to the power 2 plus 12, then times 4 plus 20. The answer that I'm going to find here, that is going to be, so 4 raised to the power 3 times negative 2, that is negative 128. So plus 4 squared is 16, 16 times 3. So 4 squared is then times 3 should be 48, plus 12 times that should be 48, plus 20. So now we have negative 128 plus 48, okay, plus 48, then again plus 48, then plus 20. That is negative 12. So that is my remainder. So my remainder is negative 12. So that is it for question 4. So question 5 is basically the same as question 4. They're just saying show that when 3x to the power 3 minus 2x to the power 2 plus 4 is divided by x minus 1, the remainder is 5. It's just the issue of us equating this equal to 0. So for x is equal to 1. So I can either plug in the value of x where there is x here, and the answer should be 5. then I've shown. Or I can use synthetic division. Using synthetic division, this is 1, so here will be 3, negative 2. We know that the number after x to the power 2 is just 0x, so it should be 0, then 4. So bring this down. So we have 3 times we have 3 times 1, that is still 3. Negative 2 plus that, it should be 1. 1 times 1, 1. 0 plus 1, 1. Then if we do that, we'll end up having 1. 1 plus that is 5. So this is my remainder. So now using this, I've shown that the remainder is 5. As simple as that. So let us look at question 6, that is talking about it's basically a polynomial, and then the question is, let f of x is equal to 3x to the power 3 minus 14x squared minus 47x minus 14. Part 1 is saying find the remainder when f of x is divided by x minus 3. So here, if you want, you can use synthetic division, or you can just do direct. X minus 3 is equal to 0, then solve for x is equal to 3. So if you plug in where there is x, you put 3, the answer you're going to find, that is the remainder. Or you can use synthetic division. Okay, so here, to make things simple, let me not use synthetic division, I'll just use direct. F of 3, it will be 3 raised to the then 3 raised to the power 3, then minus 14, 3 raised to the power 2 minus 47, then I've got 3 minus 14. So f to the power f of 3, I'll have 3 times 3 square, or 3 to the power 3 is 9. 9 times 3, so we'll have 81. So I have got 81 here, minus, then 9 times, because 3 squared is 9, 9 times 14. No, because 3 to the power 3 is not, is 27, right? 27 times 3 is 81, which is correct. Okay, yeah, it's correct. So now I have got 14 times 9. 14 times 9, that should be 126. Then minus 47 times 3. 47 times 3, it should be 141. Minus 14. So now f of 3 will be 81 minus 126 minus 141 minus 1, or minus 14. So that should be negative 200. So this is my remainder. So the remainder is negative 200. Now after finding the remainder, part 2 is saying given that x plus 2 is a factor, okay, is a factor of f of x, factorize completely. Now after knowing the factor, then we can use synthetic division now to find the rest. So the factor is x plus 2. Let's find for x. X will be equal to negative 2. So using synthetic division, negative 2 will be here, and then I'll have 3, neg 14, neg 47, neg 14. So you bring 3 down. 3 times negative 2 is negative 6. Then that is going to give me negative 20. Negative 20 times negative 2 is negative 4, negative 40. If I do minus plus, I'll get negative. I'm doing plus, right? Oh, it's negative and negative, so it's positive now. I'll end up having positive 40. So negative 47 plus 40, it should be negative 7. So if I do plus again, it will be negative 14. Negative, no, positive, negative and negative, positive. So then the remainder is 0. Indeed, this is a fact. Okay, so then now I have got 3x squared minus 20x minus 7. You just get these 3. The first one will have x to the power 2, the second one will have x, the other one without x. Now from here I want to factorize this. Now I can use product and sum. The product is 3 times negative 7, that should be negative 21. Then sum is negative 20. So the factors should be negative 20, 1, and positive 1. So therefore, I'll have 3x squared minus 21x plus x minus 7. I no longer need this part. Then I can shift this guy to go on top. Then from here I can continue now and factor out 3x. Here I will remain with x minus, there it will be 7. Not so. Then here I can factor out 1. So I'll remain with x minus 7. These are the same. You pick 1. So I have 3x minus plus 1, which is this one, and x minus 7. So factorizing complete now. Therefore, the answer is 3x plus 1, x minus 7, and the one which they gave us here, x plus 2. So I factorize completely. This is my answer. Now, without wasting much of the time, I'm going to get this guy and put it on top here, because I don't have enough space. So I'm going to get this and put it on top there. Now the second question is asking us to sketch the graph. So sketching the graph, first we need to find the x values. So equate each equal to 0. So x plus 2 is equal to 0. X is equal to 2. Another one again, x minus 7 is equal to 0. X is equal to 7. Another one is 3x plus 1 is equal to 0. Then 3x is equal to negative 1. Then x is equal to negative 1 over 3. So the values of x that we have found, how many are they? We have those values now. Okay, yeah, we have those values. So try to check the values that are found. We can clearly see that the values that are found, this should be negative, right? After shifting 2 to go to the other side is negative, yes. So I've got 2 negatives and 1 positive. So then when I do that, I think I no longer need this part. Now I can have my graph. Now this graph, we need to be very much careful. I'll put negative 2 here, and that other one which is negative 1 over 3 and 7 I'll put here. Let us look at this. There is what we call the end behavior of the polynomial. This is the first thing that you have to look at. But we know that there is a number that doesn't have x, that is going to be my y-intercept. So it has to cut at negative 14. I'll put negative 14 there. So there's what we call the end behavior of the function. So the end behavior of the function is how the graph is going to come out. Is it going to come out like that, then here going like that, or how? Now there are a few things that I want you guys to take note. Okay, and these are, if at all this guy, the guy which has got the highest power of x, if it is positive, okay, if it is positive, and that is and we know that this is an even, okay, it's an odd. Okay, so now let's not mind about that, but what I want you to understand is that if at all this is positive, so it will come out, it has to come out here, then again down here it has to come out like that. If the first guy here is positive, is negative, sorry, if it's negative, then it will come out like that, then here it will come out like that. That is if it's negative. Okay, so now I want you to understand that we have got what we call the even and odd. Okay, so you need to understand the even and the odd. But now those things can help us to know whether the graph is going to go one side or the other side. What I mean is, quite okay, you're going to find some other graphs where it's going like that. Another one is going like, you have that, then it goes like this. Okay, so there are two things. Okay, so now I want you guys to understand that whenever we are talking about, if we have got if I have got even, and you guys definitely know that if I've got x to the power 2, let me start with x. If you have got x to the power 2, x to the power 4, and x to the power 6, that is definitely what? An even. But in a case where I have got odd, which is x to the power 3, x to the power 5, x to the power 7, this is odd. So now if this is odd, then you have one graph going to the other side and another one to the other side, like the way this one is. But if it is an even, okay, if the graph is an even, then it's going to go to one side. What I mean is, when you are doing a quadratic function using completing square method, you discover that you have got a graph that goes like this. So now this goes there, or it can either go like that. So these guys go to the same side. Okay, but in this case, in most cases, polynomial, you are going to be dealing with x to the power 3. So x to the power 3, what you should know is the other one will go to the other side, the other one will go to the other side. Okay, so it can only go to this side and that other side if at all this guy, which has got x to the power 3, it is positive. So if it has got negative, it has to come out like that. It has to end there and there. So in this case, this is positive. Then the graph will come like that. It touches there, then it goes. We don't know where it's going to end. It goes there. When it comes here, then it will come and touch there. Then it goes there. So here it has to touch at 7. It comes there. So that's the graph of that guy. So we don't care where it's supposed to end. Okay, we do not care where it is supposed to end. The reason is simple, because we are not interested. But when we start doing calculus, we'll be interested in that. But for now, we are not interested in where the graph is supposed to end. Okay, so that is it for this question. So let's go ahead and talk about question 7, that is saying, let f of x is equal to 2x to the power 3 plus 3x squared minus 8x plus 3. Show that f of x is equal to 2x plus that, where a, b, and c are constant to be found. So how can we find those things? Is it okay if I can go ahead and use synthetic division? Yes, it is okay. So if this guy that we have, or is minus, equal to 0, so for x, so it will be x is equal to 1 over 2. So using synthetic division, what can we see? So using synthetic division, we can clearly see that we are going to have what we're going to have. So if we look at it very carefully, we can clearly see that if we are now going to have this. This is one of the simplest thing. So this is 1 over 2. So now I'll get that. So that is 2. That is 3. -8 and +3. Bring this down. So now we have got 2 times 1/2, that is 1. 3 plus that is 4. 4 times half is 2. -8 plus 2 is -6. -6 times half is 3. Is 3, -3 plus 0. This is the remainder. So this now becomes as x squared, 2x squared plus 4x minus 6. So meaning that this is A, this is B, and this is C. So A is 2, B is 4, C is -6. I'm done. Then they are saying hence factorize completely. So to factorize completely, I already have this. So I'll just come direct and use product and sum. So the product is 2 times that is -12. Sum is +4. Then the factors I expect to be +6 and -2. Yeah, so it will be 2x squared plus 6x minus 2x minus 6. Factor out 2x, I'll remain with x plus 3. Factor out -2, I'll remain with x plus 3. So I can get rid of this now. So I'll have what? I'll have 2x minus 2 and also x plus 3. So we want to factorize complete. Yeah. So meaning that the final answer now, factorizing completely, after reaching at this point, I need to add this. So which is 2x minus 1. So I have factorized completely. Okay. Now factorizing completely, that is the answer that we are supposed to find. So let us see. Yeah, that's the answer we're supposed to find. It's factorizing complete. Now from there we want to find, we're trying to find now we're now trying to find the values of x. So what values of x are we going to have? Yes. So equate each guy equal to 0 and so for x. So here we want to find, write down all the roots of the equation. You equate this equal to 0, you solve for x. So this one will be 2x minus 2 is equal to 0. 2x is equal to 2 divided by 2 by 2. X is equal to 1. Done. X plus 1 is equal to 0. X is equal to -3. The other one, 2x minus 1 is equal to 0. 2x is equal to 1 divided by 2 divided by 2. X is equal to 1/2. So these are the roots of the equation. So I found the values. Now they want me to sketch. So sketching polynomials, like I said earlier, so I've got x is equal to -3, x is equal to half, and x is equal to 1. Now I can get rid of everything here. Remember the end behavior of the polynomial. So the end behavior of a polynomial, this is now an odd. So how is it going to come out like? So we have one negative, that is we have one negative, that is -3. I'll put it here, and we have half and 1. So we have +3 there. Now the end behavior is that this guy is positive. So if it is positive, how is it going to come out? So it has to come here and also go there. That's how the graph is supposed to be. Okay. That is how the graph is supposed to be. So the question is 2x to the power 3 minus, or is plus actually. Yeah, we have 2x to the power 3 plus 2x to the power okay. So here now the graph has to come here. It comes there. We do not know where it's going to end on top there. We don't even care. It comes there. When it reaches there, it touches there. Then here it has to touch this point. Then it comes there and go there. We don't know where it's supposed to end. So that is my graph. Okay. So this is the graph of f of x is equal to 2x to the power 3 plus 3x squared minus 8x plus 3. When we start doing calculus, we'll be able to know where the graph is supposed to end there, the turning point. But for this polynomial, we just end there. We can't know the turning points in that manner. So that is it for this question. So let us talk about question 8, that is saying, show that x plus 1 is a factor of x to the power 3 plus 6x squared plus 5x minus 12, and hence factorize completely. So showing that it's a factor, the remainder has to be 0. Therefore, I can use synthetic division. Why have I choose synthetic division? Because the question is asking me to factorize complete. So factorizing is going to be easy when I use synthetic division direct. So what I'll do is I have to get x minus 1 is equal to 0. So for x is equal to 1. My factor is 1. So here there will be 1, 6, positive 5, negative 12. Bring this one down. So 1 times 1 is 1. 6 plus 1, 7. 7 times 1. What is 7 times 1? Is 7. Then 5 plus 7 is 12. So 12 times 1 is 12. So negative 12 plus 12 is 0. So this guy is my remainder. Now the question is, we want to show. So when the remainder is 0, meaning that is indeed the factor. So you say the remainder is 0, therefore x minus 1 is a factor of this. Done. Then now we want to factorize completely. Factorizing now, this guy will carry x, so it's 1x squared, which is just x squared, plus 7x plus 12. So the product is 12. The sum is 7, positive 7. The factors should be positive 4 and positive 3. So that 3 times 4 is 12. 3 plus 4 is 7. Therefore x plus 4 and x plus 3. Then I need to add also this factor, which is x minus 1. So I have factorized completely. Done. Okay. So for question 8, that is the answer. Okay. So let me now create space here because I don't have enough space. Okay. I don't have enough space. Let's go to question 9. Question 9 is saying, use the factor theorem. Use the factor theorem to show that. Now here I can't use any other method apart from factor theorem to show that this guy is a factor of that. So the answer that I'm going to find, the factor theorem is when you get this equal to 0. So for x, 2x is equal to 1 divided by 2 by 2x is equal to half. So factor theorem is when you put where there is x, you put half, so the answer should be 0. So where there is x, you put 1 over 2 raised to the power 3, then plus 17, 1 over 2 raised to the power 2, plus 31, 1 over 2 minus 20. So f of 1, and we should show the answer we should find is going to be 0. So this is going to give me 1 to the power 3 is 1, 2 to the power 3 is 8. Then we have got 17. This is going to be 1 over 4 plus 31 over 2 minus 20. So let's see, f of 1 over 2. So this is going to be 4, because 2 times 1 over 4 over 8 is just 4. Plus this is now 17 over 4 plus 31 over 2 minus 20. So this is the same as over 1, this is the same as over 1. The common denominator is 4. So 1 into 4, 4 times 4 is 16. Then plus 4 into 4 is 1, 1 times 17, 17. 2 into 4, 2 times 31, it is that what? It is basically 62. Then 4 times that should be 80. So now if I do 16, okay, so if I do 16 plus 17, then plus 80, where have we gone wrong? So let's just do it again on top here, because I'm supposed, if it's a factor, the question is use the factor theorem to show that this is a factor. So when we plug in the values, the answer should be 0. So here I can clearly see that it's not going to give me 0. So I've already made a mistake. Direct, I've already made a mistake. So we have, wasn't this supposed to be 2 over 8? Yes. Of which if I reduce it, it's the same as 1 over, so it's 1 over 4. So here there was a mistake here. This one, because 2, we are doing now 2 times 1 over 8, so it is 2 over 8, 2 there 1, 2 there 4. So it's like this. Now 4 into 4, 1 times 1, it should be 1. So this is not 16, it should be 1. So it is 1 plus this is 18. 18 plus 64 is 81 or 80. 80 minus 80 is 0 over 4, which is 0. So f of 1 over 2 is equal to 0. So therefore we have used the factor theorem to show that that is the answer. Okay.